In this video we are going to attempt to service the output side bearings of a Shimano dynohub. In the last video I removed the internals from the hub shell. I'll provide a link to that video here. If you look at the top of your screen, you'll see a link to that video now. So a little bit of the backstory of this hub. It was sent to me by a gentleman who had said that it had stopped producing electricity. And so anyway, he sent it to me to do some failure analysis. When I took it out of the package, it actually did work. I hooked a light up to it and tested it, first with a multimeter and then with a light, and it was producing full voltage. Matter of fact, I will insert a video clip here that shows that test. Okay, so I've got it rigged up here to give it a little test. I have a Herman dyno light hooked up to it here, just with a set of alligator clips, because I do not have a proper clip for it. And I've wound a string around the hub. If you're old like me, you remember winding up your starter on your lawnmower before they had the recoil start, so it's kind of what I've done here. So we'll give this a pull and we'll see if it generates some light. Well, look at that. It's doing pretty good for a hub that wasn't working. Okay, so you saw it functioning there. So anyway, carrying on here, we're now going to attempt to service the power output side bearings, as I said before. Now Shimano tells me, because I talked directly to them, I actually called their service techs, and what they told me was that this hub is not, in their words, it is not maintainable. They said that the bearings on the non-output side are serviceable. It's just a regular cup and cone bearing, loose ball. But their claim is that the power output side is not serviceable. And so once the bearings are shot on that side, what you're supposed to do is just buy a new internal assembly and remove the old one, as I demonstrated in that previous video, and insert the new one, and there you go. So anyway, today what we're going to do is we're going to attempt to access this bearing and see whether we can in fact service it. No manual exists for this. This will be a voyage of discovery, and I've not done it before, so you'll be going on this voyage of discovery with me, and we'll see how we make out. So the first thing we need to do is remove this lock nut, 17 millimeter. It's not on there very tight. And then the connection box, I'm assuming there'll be a wire there. Okay, so I see one wire. Looks to be a single lead, and this connector has no wire leading to it, so it appears that the axle is actually the power path for one side, and then a lead to this other connector. So what we've got here is some five-sided nuts. It appears that they are shaped that way to mate with this hole to keep this oriented in the correct direction. And there's a little tongue there, so I guess it's not going to unscrew, it's going to lift right off. Well, there's actually two of them. And keep these in the order that they came off. Let's see what we got now. Alright, so we got a little groove there that wire can fit through, but to get the these parts off, this will have to come out of the way. So I'm guessing that connector is probably going to have to come out of there. And okay. All right. So if we fit that into that groove, we can get the rest of these parts, hopefully, out of the way. It looks like a bunch of insulating material around there, so maybe have to put some liquid tape around there later. So let's see, this turns in relation to the axle and it's actually unthreading, so that's a good sign. And with that wire tucked into that slot in the axle, we should be able to get that up and out of the way, and we'll see what's underneath there. Okay, so that cap threaded all the way off the axle, and looks like the cone is actually integrated with that cap. It's pressed in there. So, and what we have here is looks like a little rubber seal, and it looks like it's directional because it's kind of cone shaped. So keep that facing up, and look at there, we got loose balls and bearings, races, and we can lift it right off of there. Who says you can't service these things? So really it appears that there's not really a lot to go wrong with this thing, other than the possibility of connections getting burnt or whatever. And the other possibility is that this wire, it is insulated. If the insulation was to wear through, then where it contacts the axle, then it could create a short. Other than that, there's not a heck of a lot to go wrong with this, as I can see it. So inspection of the cups and cones shows that there is no wear. Everything looks good. So we will reassemble. Alright, so I'm not going to go into long boring detail on reassembling the cup and cone bearings. Plenty of other places online that you can find that. Now it occurred to me a little too late that I should have measured how much axle was protruding before we unscrewed that, because this does not bottom out, but in any case we can kind of estimate and go from there. So now we put these parts back in place in the order they came off. Okay, so that wire was on top of that, and then there's a groove on the underside there that fits into, and then the Second one on top like so. Make sure nothing's being pinched there. And the lock nut. Okay, so that wiggle would be normal. After that's threaded into the shell, the bearing adjustment will be made from the other side. So now the next step is to thread it into the shell. Alright, so now we torque down the lock nut here. 17mm cone wrench will fit underneath the connection box there, although snugly. This might have been one of the issues why it didn't work, because the axle is one of the electrical conductors. Really the only thing that gives it a really good contact is the lock nut on this contact here. So aside from the fact that lock nuts should be properly torqued down, it also in this case provides for the electrical connection that we need. So now before we adjust the non-output side bearing, we want to make sure that the ring is tightly screwed in. So once again, I'm going to put 3 spokes in it and clamp them in the vise. And this time, rather than using the tool, I'm just going to use a brass punch and just give it a few taps there to make sure it's torqued in there properly. So all that's left is to adjust the non-output side. The cone flats take a 17mm cone wrench, and it's just a standard cup and cone adjustment procedure. Alright, so it's time to give it the spin test again with the light hooked up and see what we got. We have power. So, a couple of final thoughts here. I think that the reason that the owner experienced a failure of power conductivity was probably something to do with the lock nut being loose, because it requires a good contact here. The bearings are easily serviceable, I find. I don't think that for Shimano to say that they're non-maintainable, I really don't think that that's true. I think it was quite easy to get in there and service those bearings, all things considered. To do a bearing service did not require the removal of the internals. That was, just to service the bearings, that's an unnecessary step. The only reason to remove the internals would be to actually replace them, to swap in a new set. But, I mean, in the interest of science, we had to go ahead and do that anyway. So anyhow, yeah, good as new. Very simple device. There really isn't a lot to go wrong, other than the possibility of fracturing the lead, or having the insulation scuff off it or whatever. But yeah, overall not that hard to service.